Can you got it right? And let's go back to the beginning. Right. So can everyone see and hear that?
Yeah, that's perfect.
Okay.
Thank you.
Right. Okay. I'm Richard Forrest. I dabble in plesiosaurs to some extent, and other marine reptiles to a lesser extent. This talk is really about excavating marine reptiles. Through my membership of the Stanford Geological Society, a volunteer for Peterborough Museum, and also now for our new group, I've been involved in excavating a couple of quite important specimens, and those are what I'm going to talk about today. First, a sort of a quick run through Jurassic marine reptiles. We have ichthyosaurs, and there we have my friend Dean beside the new one from Rutland Water, which is absolutely enormous. It's a 10-meter long ichthyosaur. Marine crocodiles, you don't hear about them as much, but they're in some ways the most interesting of the lot. They're crocodiles which went all the way back to the sea and had a lot of marine adaptations. And of course, plesiosaurs, which are of course the most interesting. This is actually the very, very first plesiosaur. It's a specimen put together by Mary Anning from bits she found on the beach. Didn't have a clue what the animal looked like, but this is actually was the first plesiosaur ever figured. So this is not just the holotype of Plesiosaurus, it's the type for plesiosaurs in general. It's in Oxford Museum, which is rather nice. Well, plesiosaurs are on the sea. The land was dominated by big dead chickens. We don't bother about dinosaurs. They're boring things. They're quite interesting, but I find them boring. Okay, plesiosaurs. Important part of marine ecology from the end of the Jurassic to the end of the Cretaceous. So a very long time during which they were pretty dominant in the marine ecology. Typical plesiosaur you see here, described once as a snake threaded through a turtle, which is partly true, but it gives an idea of what they looked like. Smallest, possibly less than a meter long. We have odd little bits and pieces which suggest tiny plesiosaurs, and the biggest were as much as 15 meters long. I have to say possibly even more than that, but that I can't talk about that at the moment. In broad terms, they come in two morphologies, big heads, large bodies, and long necks and small heads, informally as plesiosaurs and pliosaurs. So that's plesiosaurs, and this is a gross simplification, but unless you want this to go on for 3 hours, I'll better stop at this point. Okay, Jurassic plesiosaurs, which we're talking about in particular, you find them all the way through the Jurassic and every period, except the Lincolnshire. Don't know quite why, partly because we have very few deposits of that age. And also we don't have any named taxa from the Lincolnshire from anywhere in the world, although there is one from Switzerland, which might be coming up soon. And then we go all the way through up to the Tithonian. So basically almost throughout the Jurassics, we have plesiosaurs in pretty well anywhere you find marine deposit. In the UK, we find them in the lower and upper Lias. We have great specimens like this. It's now Anningosaurus macrocephalus. This is one of Mary Anning's specimens in the Natural History Museum. This one is the Toarcian. It's a cast of an animal called Romaliosaurus cramptoni, of which the original is in Dublin, and casts of which were distributed all over the world. Something to note actually is that that leg was missing from the original, which is why that leg and that leg are identical. A lot of the casts were reconstructed, not terribly accurately, because that actually is that's a humerus. Anyway, but most specimens come from Eastern England. Generally speaking, in the Lias, plesiosaurs are rare, ichthyosaurs are very common. When you get into the Colovian and the Oxfordian and the Kimmeridgian, plesiosaurs are much more common and ichthyosaurs are much less common. So they come from the Clunch clay and shale and the oak tree clay. These are illustrations from a wonderful book produced by I think it was the British Geological Survey, which showed the figures from William Smith's original collection of fossils and the names he gave them. They've identified a lot of the fossils from the collections they have at the British Geological Survey and at the Natural History Museum. But nowadays, of course, we know them as the Oxford clay. See this great swedge of red down there, which actually goes all the way down to Dorset as well. Particularly the area around Peterborough is very, very well known for marine reptiles. And the Kimmeridge Clay, which again stretches all the way down to Dorset, but we have extensive deposits all the way through Oxford, Cambridgeshire, and all the way up through Lincolnshire. Start looking at a plesiosaur from the Oxford clay. The Oxford clay is very rich in marine reptiles. It was heavily exploited for bricklaying. It still is. There are still very big brick pits in the area, although collecting is not as easy. Back in the 19th century, a lot of excavation was done by hand. You had men standing at the top of the face with long crowbars, levering off great chunks of clay, which then were taken by trolley to the brickworks. The Oxford clay is very good for making bricks because it has a high organic content. Now, this means that if you build a clamp of bricks molded from Oxford clay and heat them up, they start firing themselves after a while once the temperature gets high enough, which essentially means you can produce bricks at a lower cost because you have less energy than for most deposits. And this is why it is such a valuable resource. We think there are vertebrates all the way through the Oxford clay. We know some of the upper beds, particularly, they're much less common. Within the Oxford clay, we talk about beds 1 to 10 all the way up to, I think, 24, numbering from the bottom upwards. Generally speaking, there is an idea they're most common in what we call bed 10, which is a bed you find at the bottom of most of the pits with these big nodules, some of which contain marine reptile bones. But it's not, I think it might be an artifact of excavation because the finds we have made more recently have been from beds other than bed 10. They're all the way through beds 9, bed 13 and upwards. So this really is the beginning of our story. So it starts in June 2016. Back at the time, Vivacity was the company which ran Peterborough Museum. They no longer do. They went bust like so many other people did. Our friend Darren finds a nice bit of wood, and then he finds some bones, which you can't see to everyone in this picture, but that actually is a fragment of bone sticking out. And then the rest of us got involved. We found more bones. And at the end of the day, a lot of bones. Perhaps not terribly clear if you're not familiar with plesiosaur anatomy, but that's a neural spine, one of the bones that stick on top of the vertebrae. These are neural arches, which are the bits that sit on top of your dorsal vertebrae, and these are face upwards. So the vertebrae would have been lying across the top there, and they have been lost or rolled away or scavenged. Here's another picture of that. So you've got the trusty estimating pick, one of the best tools there is for scale. So it was obviously we had something important, and that needs systematic excavation. There is an urge just to collect the bones, but we really want to get a proper idea of what we're looking at. We're able to identify the animal as Cryptoclidus, basically from the morphology of this femur there. It's a long-necked plesiosaur. They're relatively common in the Oxford clay relative to other plesiosaurs, but this is a juvenile, which are much less common. We tend to, with Cryptoclidus, have quite a lot of big adults and very few juveniles, and not much in between, which is rather odd. So we need permissions. Pits owned by Forterra, they were very cooperative, helped particularly by Andrew Mortlock, who keeps an eye on us when we're down in the pits and finds the occasional dinosaur bone. An urgent need to get the excavation underway as soon as possible. Exposed bones left in situ will tend to deteriorate, and also there's the risk of toe rags, and that draw your attention to that. The local knows who we're referring to, who will go into the pit and steal bones and just take them. So we covered everything up to make the site a bit less obvious, but everything had to be agreed with Fortera and Peterborough Museum before we could start. So a little bit about the Oxford clay. I've mentioned bed 10. This specimen comes from bed 9, just below bed 10, which is the modular bed. One thing we did find during the excavation is that it's seems to be particularly rich in fossils. Whether that's just because we were concentrating on it or because there are more, it's hard to know. But I mean, this, for example, is a teuthid, which I think of as Bellomateuthis, but it's not. There's a proper name for it. But this is much bigger than any other we've seen before. And Andrew Mortlock found this bone, which is the toe bone of a dinosaur. And dinosaurs in the Oxford clay are very rare. It's a marine deposit. We get thousands of marine reptiles, but generally speaking, the only dinosaurs we found are the odd bits and pieces which have been washed down the rivers and out to sea. So I think for probably thousands of marine reptiles, there's only a handful of dinosaurs. So one thing we did say, there were no nodules immediately above the specimen, but we found that the bed there is very, very hard. And below the bones, the clay is very friable and doesn't fracture neatly, which was a bit of a problem during the excavation. Lots of paperwork, of course, but importantly, from a practical point of view, is methodology for the collection. So method statement, and I hate doing this, but there are bullet points. So looking at the clay below it was very friable, which means impractical to jacket the bones and plaster, which is a common method. You can do it very well where you've got a nice clean bedding plane underneath where things split. But we have experience of jacketing bones up when it's not on such a good enough substrate and lifting them, and the whole lot just drops out of the jacket, which is not ideal. Normal practice, especially for these things, this is a technique developed by Alan Dawn over many years. Trace the outline of the bones on a plastic sheet to record declination before lifting. And this was included. Number each bone. This is very important. Record in the notebook, photograph in situ, standard label, and actually added to a database as well. Lots of general shots of the excavation area to record progress. Those of you who are as old as I am will remember when we went along with the camera and 2 rolls of 35mm film and were limited to 36 exposures, each of which cost us about 10p. Nowadays, you can take thousands of pictures, which is fantastic. The other thing I wanted to do with this excavation was to use photogrammetry, which I'll talk about a bit more later. And that means setting up key markers which can be measured and then used to scale 3D models. So 26th of June, excavation starts in earnest, and I like this quote: "No plan of operations extends with any certainty beyond the first contact with the main hostile force." So there was no transport available, so we had to carry all our equipment down into the pit. It's about a quarter of a mile, and it's hard work. And it didn't stay this clean for long. Not to the clay pit's hostile force, but it poured with rain all day. So everything was wet and muddy. A digger was supposed to come and help us remove the overburden, but it was busy elsewhere, so it didn't turn up till mid-afternoon. We found the clay was so hard that it was impossible to drive in aluminium tent pegs. We had to set up markers. Basically try to hammer them in, they just bend. And because it was so wet, we couldn't get the markers to write on the plastic sheet or write reliably on the melamine faced label that I prepared. So this was a bit of an issue. However, we did manage to pin down some of these right angle scale bars I made, which are 50 centimeters aside, and because they're right angles, we can retro deform from them. Numbers a bit faint, still legible, so good enough. And in spite of the rain, I was able to take decent images, even though my camera was in a bit of a mess by the end of the day. But it tested the claims of the manufacturer to be weather and dust proof, and it performed perfectly. So kudos to Pentax. Right, getting to the bones, very hard clay. We used a variety of tools. Most effective is what we call the psycho knife. Basically, it's a cheap kitchen knife. You can try to drive into the layers of shale and split it, which works extremely well. You can see her using it in a way which is probably going to end up stabbing David in the face, but it happened. It worked. Darren came up with some flat steel strips, which are called withers wedges, which could be hammered in to form a fracture. So that was useful as well. And of course, if anyone's ever excavated anything, we use all sorts of things from paint scrapers, brushes, dental picks, palette knives, and anything else you can get your hand on to try to do it. So you can see a variety of the tools here. Right, the specimen came from the side of a wide trench dug for drainage. So we find, first of all, we find many additional bones in the spoil below the place we found the plesiosaur. Frustrating little bits like this, which actually have nice, clean, broken ends, which means there must be more of that rib somewhere, but we couldn't find it. Some of the spoil had been obviously dumped on the other side of the trench, and we actually found some quite important bits there, including skull elements and vertebral centra from the neck, which was great, and other bits as well. This actually is a crocodile vertebra. Again, when you have things from different areas, you can't automatically assume they come from the same individual, but all the Cryptoclidus bones we found were of a juvenile. They were consistent in terms of size. We didn't find we had, for example, 3 femora or 3 humeri. So we didn't have any duplicated elements. And if we think about it coherently, if we're getting the back end going into the face of the trench, which we're excavating, and the front end dug away, then it's entirely consistent with getting bits from the front end of the animal. So one of the other places we might have more of it is at King's Dyke. King's Dyke Nature Reserve has a fossil collecting area, and every so often Forterra jumps a few tons of the clay in the area, and some of the clay which they dumped came from that drainage trench which they dug through our specimen. So some of our members found more cervical vertebrae from a juvenile Cryptoclidus, which are probably from the same specimen, but it's really virtually impossible to be sure. One of the techniques I tried to use as excavation was photogrammetry. This is a way of taking a lot of photographs of an area and then using a very clever bit of software which puts everything together to get a beautiful 3D model. And from the models you can scale and create an accurate map of the area. I had some problems with this. I had some software which I was using, but it took a very long time, over 24 hours, to process the images. And the result wasn't terribly good. So I got this bit disheartened by this. However, I got in touch with my friend Peter Falkingham, who's at Liverpool John Moores University, and he knows all about photogrammetry and so on. And he helped me out greatly, processed my images, produced some excellent models, and I'll be using them when I write everything up. So here's a slide of a model he produced. You can see this is going through the stages of the excavation, bit at a time. And you can basically see from the model the way in which we were able to record the bones at each stage and therefore be able to create a proper map of everything in situ, which I'm very keen on as being important to record the taphonomy, what happened to the carcass on the seafloor after the animal died. And I think this is going to be fantastic for doing that. So I'll let you watch the models. I still find them enthralling. Okay, so I also obviously have these as models, which I can then use and manipulate and use in different ways. Okay, so systematic excavation produces valuable information. We know it's a juvenile animal. Here's the femur. It has a rounded end, which in adults becomes much more strongly faceted. We have the neural arches, which are loose and unfused, and various pelvic elements. Here's one of the pubes, which got this sort of rather soft, rounded outline, because it isn't fully ossified. It's the same thing as you find, what they call the fontanella in a baby's head, which is soft, and the bones grow as the animal, as the baby, sorry, gets older until you have a hard skull. The same thing happens with most juvenile animals, except pterosaurs for some reason. But anyway, and this is a picture of, that's the bottom of the neural arches lying down in the mud. We have some indication of scavenging. Can't see it very well there, but there's a tip of a tooth embedded in that bone. And we had other interesting things. For example, vertebrae which had been bitten in half. We found 2 different halves separated by several centimeters with a tooth mark in between. So the animal had been scavenged. And it went off to Peterborough Museum. And here it is, cleaned and laid out. And it will be going on display like this soon. You can see we have the skull elements, we have a lot of the skull, we have a lot of the vertebral column, 2 humeri, whoops, one of the femora, and a substantially complete animal. We don't always get them like in Jurassic Park. So it's going to be put on display in Peterborough Museum later this year. I'll be working with the Peterborough group on getting everything ready for display and making it a specimen which tells a story, which I think is always very important when we're talking about fossils. They're not just objects you put in a case, they are animals which had a life, which died, which were dismembered, which were scavenged. And it's a little bit of a story, a window into the past. So a few more pictures. Up next. We have other things as well which we're going on, and we need to sort of get some research going on this. We have matrix collected from the immediate area above and below the specimen. We see if there's anything distinct about the clay, and we will be writing it up as scientific papers, both talking about the excavation and also about the taphonomy and the anatomy and taxonomy of the animal as well. So there's papers to come out of this, which is important. So watch this space. They have Darren Withers, who is the guy who found it, Glenys Was of the museum, and that's David Savory's back. And thanks to this, of course, Patera, who are brilliant, particularly Andrew Mortlock, who keeps an eye on us on all her field trips. Peterborough Museum and Vivacity, volunteers, here we have, whoops. We have all our volunteers list, and particularly Darren Withers, who found the specimen and is one of the best finders of fossils I know. He's absolutely brilliant. But anyway, that's one specimen. We now go on to the Kimmeridge Clay, and I have to say we're quite a long way from Cambridgeshire, but we're still just about East Midlands, about as far north in East Midlands as you can get. So the Scunthorpe pliosaur, right. So we had a field trip, the Stamford District Geological Society in 2017 to a quarry in North Lincolnshire, unfortunately now abandoned, but that's another story, which is chalk overlying Kimmeridge Clay and Ampthill Clay below it. Great field trip, we found lots of fossils, beautiful little ammonites, and then Darren found some vertebrae. I said, oh, that's interesting. They're short, round vertebrae. They're probably ichthyosaur. And here we have, of course, we have Buddy Rich doing a drum roll. Do it. But imagine Buddy Rich doing it. Darren found that. And I said some choice words. I said, that's not an ichthyosaur. Oh my gosh. I didn't use quite those words. It's a pliosaur jaw synthesis. I got quite excited. Initially, I thought it was the tip of the lower jaw, but I cleaned it up and went around to see Mark Evans with it, who said it's the tip of the premaxilla, it's the tip of the snout, so, and the upper jaw of a pliosaur. And it actually had a box of vertebrae which Darren gave me to bring along, and he pulled this one out and says, "That's not a vertebrae, it's the atlas axis. It's the bone which is the first bone of the vertebral column where it connects to the skull." So why the excitement? So pliosaurs were top predators. Some of them were huge, possibly the most powerful predators of all time. Here's a wonderful specimen, the Weymouth Bay pliosaur, which I became involved with in Dorchester Museum. The skull is over 2 meters long. And here I am telling David Attenborough all about pliosaurs, back in the days when I didn't have so much of a beard. And this pliosaur particularly gave a lot of press coverage. This is when I had my 15 minutes of fame, and it hit the news, and it was on the news all over the world, and even got a cartoon in the Times. Let's talk about the Kimmeridge Clay. So vertebrate fossils in the Kimmeridge Clay haven't been studied as much as the Oxford Clay, but it hasn't been quarried on the same scale. It is an economically important deposit because it's a source for North Sea oil. But obviously, if you're pumping oil out of it, you're not going to find many fossils. Where it has been studied, it's shown to be much more varied collection of fauna than we ever thought. And here, of course, is the best museum in the world. It's the Steve Etches Museum in Kimmeridge. This is all fossils, or pretty well all fossils, which Steve has collected personally from the Kimmeridge Clay in the Kimmeridge area. And here's Steve holding our jaw synthesis. I went to see him with it because he knows a lot about the Kimmeridge Clay. So we are back on the 24th of March and found more bone. So here's the side of a humerus and more bone. This was found on that trip. You can see a humerus, it's about 60 centimeters long, which is pretty good. There are bigger humeri from pliosaurs. Generally speaking, Kimmeridge Clay fossils tend to be more scattered than we'd find them in the Oxford Clay, although actually thinking about that, it might just be that the Oxford Clay specimens, because there are so many more of them, we tend to concentrate on the nice articulated ones, but possibly the error is proportionately common in the Kimmeridge Clay, but we have fewer specimens. Went back again, found more bones, and it was clear we didn't just have a few scattered bones, we had something much more substantial. And again, we talked about systematic excavation rather than just collecting bones. So, drew up plans for a systematic excavation, blah, 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 an awful lot of words and comments of scientific importance. So, said basically, dig from the top of down as the bed which your bones are lying is uneven and faulted. Make detailed photographic record as we go along, including all bones in situ. Use a grid frame to record the position of all bones in situ. At that time, I was having real problems with the photogrammetry, and I wish I'd talked to Peter Falkingham earlier. I'd have done a photogrammetry on this as well, but we got good results just by using a grid frame. Consolidate friable bones before lifting, because one thing that was very obvious looking at the bones we'd found is they're very soft. Some of them, particularly the ribs, were the consistency of wet cardboard. So you need to be very careful with them and use plaster jackets. So here we are, 4 hours of digging, and we have vertebrae, we have some ribs. You can see the size of the ribs here. Everything in situ. Darren and Mick slacking off, of course. They should have been working, not drinking coffee. This is an area about 2 by 1 meters. I estimated the length of the animal to be about 8 meters, so we might have to, the carcass might be scattered over a very wide area. So it might need a lot of digging. At the time, access to the site was limited to occasional Saturday mornings. So we didn't have much time to do it. We'd have a window of about 3 or 4 hours on about one Saturday a month to go in and dig it. and it's obviously not going to get anywhere that way, especially as a lot of the work was just removing the clay lying above it. It was about 1.5 meters of clay to get rid of. So this could take a long time. However, Cemex, who are the quarry owners, and the Alf Kitchen, who are the operators, were incredibly helpful. They allowed us in the quarry during working hours. They lent us a digger and a driver for 2 days, which was absolutely fantastic because they could take off 1.5 meters of clay in 2 minutes, which would have taken us a whole week to get rid of. And digger drivers, in my experience, are incredibly good. They can go to within 1 inch of where you want to go, 20 centimeters, 20 millimeters to those of you who are more modern, and it made the whole thing possible. So here we are today, numbering all the bones in situ before lifting. So lots of photographs again, recording everything in the notebook, putting a labeled bag and putting them into a plaster jacket. In this place, the clay was not that blocky stuff we had in the Oxford clay pit. It was actually much nicer to work with. It tended to come apart on nice layers, so we could jacket and lift quite safely. We also took a lot of photographs of the space left by the bone after lifting, because here's a gap where there was a vertebra. And when you look at it closely, we have tracks underneath it, showing that these bones were lying on the sea floor. There were worms burrowing underneath it. They were there long enough for oysters to grow on top of them. So a lot of colonization of the carcass. And again, as I said earlier, fossils tell a story. This is telling a story of a huge carcass decaying on the sea floor, being scavenged, animals growing, oysters growing on it, and so on. And I'd say, that we've kept all this sort of evidence. This is a sort of material which a lot of commercial preparators will get rid of because to show the bone. But I think in this case, we made sure that it was kept because it tells it's part of the story of the animal. Some of the bones were dreadful condition. Here's a rib. That is quite literally the consistency of wet cardboard. Horrible to work to try to excavate. So we basically flooded them with paraloid and acetone to consolidate as much as possible. Paraloid is a conservation grade adhesive. You can use it diluted in acetone at different strengths for different purposes. I'd have to say, generally, when I work on specimens, I have a sort of 5% to 10% to 25% and 50% solution for different purposes. This is a fairly weak solution, but with plenty of acetone, so it penetrates into the wet bone. This is what I made to record the location of the bones with a mobile phone used as a compass, then sketched onto grid paper. There's the compass thing, Rick. Using a mobile phone proved to be a bit of a mistake because I found when I started stitching things together that some of the things were as much as 30 degrees out. Mobile phones give you the false impression of accuracy, even when they're not. I'll use a magnetic compass next time. At least it'll be consistent. The bones were lying in some places in these large Rossenia ammonites, which are help to establish exactly where they sit in the stratigraphically. Here's Paul Hildreth, who did a lot of work when we were digging up the specimen, as well as helping us, I have to say. He produced a very detailed section of the pit with the help of Mike Oates, who lives nearby and actually put some of us up for the night, which was very nice of him, and knows the invertebrates like it extremely well, should we say. So he was a great help. Together they produced this. So here's a photograph of, there we are digging away at the pliosaur. There's the Kimmeridge Clay. And that is exactly where it sits stratigraphically. So we have brilliant provenance. Quick word on provenance. I mean, it's a lot of historic specimens, especially on the fossils I work on, which are a lot of Oxford clay specimens. The provenance tends to be Oxford clay Peterborough, which is of limited use because For example, I've looked at a plesiosaur called Rhinoceros in the Oxford clay, looking just at limb bones, and found out that they plot off it as 4 different clusters. Now, what I don't know is are we looking at 4 different species living at the same time, or are we looking at changing the species during the duration of the Oxford clay seeds, which was a couple of million years? So to get detailed information exactly where those finds are stratigraphically is very useful and really helps us build up the evolutionary history of the taxa. Although I did have to say, I did come across one named Jurassic Russia, which is a lot less helpful. So this is all one of the reasons why we like to do these things very carefully and systematically and record as much as possible, and also keep a lot of stuff which at the moment may seem useless, but who knows what use it's going to be in future. By the second day of the excavation, it's becoming clear that we'd found most, if not all, the bones which are still in situ. Unfortunately, it seems like a lot of the bones had already been lost to the quarrying, including, sadly, most of the skull. It was frustrating to get the tip of the snout and the first bone of the vertebra and nothing else. We went 2 meters beyond the last bone and basically didn't find anything more. So then it's time to wrap up. So there we have lots of ribs jacketed and ready to be transported. Boxes of bones in bags and so on. Fortunately, we had help of a Land Rover to get everything back up to the top again. I'd hate to have carried that back up to the top. And this is what we found. So here's a drawing of a plesiosaur, of a pliosaur, based on some work. I don't think it's actually that accurate. I think the neck is too long. But anyway, the red bits are the bits we found. You can see the tip of the snout and those bones are humerus, quite a lot of ribs, and what I think is actually a fairly complete vertebral column from mid-dorsal to the atlas axis. One of the things when we managed to get back to Scunthorpe to look at the bones now is to do some statistical analysis of vertebral proportions, which is my thing, and to figure out if we have a more or less complete neck there, because that would be very useful and really important bit of information. We also have this nice excavation plan, which we'll be able to do from the photographs and from drawing up from the grid. And you can see it here, it forms a decent pattern. One thing that's interesting here, and immediately sort of struck me, is if you look, there's a line of vertebrae, and the ribs are almost right angles to it, which is probably telling us something about the way in which the specimen became disarticulated as it rotted. Curiously, Michael Oates, who was with us in the dig, back in '87, helped excavate a pliosaur near Aylesbury, which actually, looking at the size of those vertebrae, was substantially bigger than our Scunthorpe one. And here's a rather poor picture from the geological curator. But you can see there's something actually quite similar here. We've got a line of vertebrae, then a line of ribs going off at an angle. So it's possible we have something, again, telling us something systematic about the way in which these large carcasses of pliosaurs decayed. So specimen needed to be conserved and prepared, and this was very much a specialist thing. So we got grants from various people, and we got Nigel Larkin, who is probably the best in the business for scientific preparation, to do it for us, and a friend of the society and a personal friend as well. So Darren and I went off to deliver it to his workshop. Here it is, all laid out. Very nice. When we first found the specimen, we said it has to go to a public collection. We talked about various things, but it needs to go to a museum with facilities for storing it and the specialist knowledge to look after them. Fortunately, Michael Oates and Paul Hildreth, both involved in the North Lincolnshire Museum in Scunthorpe, and are familiar with it. And it's only a few miles from the quarry, so we offered it to them and they were very pleased to have it. They had It was accessioned by the museum, and we had a Pliosaur day, which hit the news in a limited way, but a lot of local news coverage. There we are. Top predator. There it is. And we announced it in the press. I did a little talk about it. We have to have the school children there. And the mayor with his gold chain. And there are all the bones laid out on top of the huge cutout I did of the skeleton. And here are some experts studying the bones. There's Mark Evans, who knows more about plesiosaurs than anybody else in the world, including me. And here's Darren, who's got the tooth. We found there's one tooth, not a very good one, stuck to the side of the humerus, and another tooth we found actually as we're lifting one of the ribs. It's a tooth near the back of the jaw called a ratchet tooth. It's hooked backwards, which helps drag the prey into the maw of the animal. So again, special thanks to Semex in our kitchen, who are brilliant. And of course, all the diggers who help make things happen. There's Darren Withers, Mike Beeson, and David Savory, John Green, Mike Oates, William Thornton, Paul Hildreth, Karen Philbin, Ken Nye, and Robert Coley, who all helped us with it. Just a little bit about our new group, because we haven't been around for long, but Stanford History Geological Society was formally wound down in 2019. It was set up by Alan Dawn in 1982. He died in 2010, and this is a memorial which was set up in Stamford towards the end of last year, which commemorates his work on fossils and other things as well. Ken and I took the initiative and set up a new group, the Peterborough Paleontological and Geological Group, to carry on with their program of fieldwork trips. And we formally established it in 2020. One of the founding commitments is what we call ethical collecting. We actually have a rather cheesy Latin motto, nos fodere enim scientia. We dig for science. What that means is we record as much detail of provenance as possible for any specimen of scientific interest. We make sure they're prepared and stored in a responsible way. We alert local museums in the first instance of finds to support awareness of local heritage, which I think is very important because these are local interest. Donate scientifically important specimens to museums, universities, or other institutions where they will be studied and or displayed. I think this is very important, not just for us, for others sort of similar groups, because too often fossils are donated to museums, they go into a drawer and they're not seen for the next 100 years. And often a lot of the details are lost, but we want to be sure that doesn't happen. So it's not just we give stuff to museums, but also museums have responsibility to do something with them. So we keep a record of significant finds and make these records available to genuine researchers, and collect only fossils which would otherwise be lost to quarrying or erosion or weathered out naturally. And we don't collect fossils for commercial purposes. Of course, this immediately after we set up the group, the world stopped. So we're picking up the pieces again now, beginning to get back into quarries, finding more vertebrate fossils. Here's the humerus of Marinosaurus, which one of the members found. No complete notes yet, but give it time. Some of the finds are on display at Flag Fen Archaeology Park, which is just outside Peterborough, where we have an area to display our fossils. There is talk about a more substantial museum for geology of the area, being built, and we're hoping that we can play a significant part in that. One of the finds we've seen is this rather imposing partial woolly rhino skull, which one of our members, Nick Oliver, found, which is looking pretty good. It's in Flag Fen. We're planning to set up a program of talks and other events as the group gains members. You can find more about us on our website, peterboroughgeology.org. And if you're a member, there's a lot more there which you can learn about. And that brings me to the end. Okay.
Well, thank you, Richard. Well, that was really interesting. I say I've wandered about in various quarries in my geological life, and I never found anything anywhere near as interesting as any of that.
Yeah.
So no, that's not quite true. I found something in Lincolnshire just once
Yeah, cool.
that ended up in Bristol Museum.
Yeah, what was that?
I think it was most of an ichthyosaur.
Oh,
At
cool.
the end, they got out. But we couldn't spend long on it because the pub was shutting.
Yeah.
Okay, we've got some questions in on chat already.
Right.
So if I can read them out. The first one is from Martin. These things apparently survived unchanged for tens of millions of years. Was the environment so unchanging that these organisms survived as distinct species for that period, or as a gradual change?
Well, one of the things I did mention was this importance of provenance, of knowing where things stratigraphically. So in some cases, we don't know if we're looking at species which changed or into something else over the time, or a single species which stayed there for a long time. Generally speaking, that there's a rule of thumb when you're dealing with mammals, at least, that a species doesn't last longer than 1 million years. I don't know how applicable that is to marine reptiles. The thing to bear in mind is that we have, when you consider the number of reptiles which must have been around during that time, and the Oxford Clay seeds, we're talking about 2 million years, and there were probably millions of reptiles around at any time during that period. The number we have is such a tiny fraction of the whole that we may have a very distorted view of just what the populations were and how many there were. Because obviously the only ones we find are the ones which have died under the right circumstances, which haven't been scavenged, which haven't been eaten. And so we may be looking at a very skewed view of the population. So it's very hard to answer questions about like how long did those species survive. Things that we don't know. We can make educated guesses, but that's about as far as we can go.
Okay, thank you. Next question comment from Malcolm Hart. He's saying that taphonomy was mentioned as important, but what exactly has been investigated?
What? Sorry, I missed the first part.
What taphonomy was
yes.
mentioned has been important,
yeah.
But what exactly has been investigated?
So far,
bones aboard by worms.
Well, we've looked for bones with worm borings. We haven't spotted any worm borings on the bones themselves. There are these things called ossidax worms which bore into bones and in modern carcasses. And they have been identified on upper Cretaceous plesiosaur remains, but as far as we know, they weren't around during the Jurassic. However, I don't think anyone's really looked for them. So one of the things we'll do once we can get back, especially to the pliosaur, is to go over things very carefully with a microscope and see if we can see any worm borings, because it would push back the origin of those worms. Again, look at the taphonomy. We'll be looking at, and again, obviously because of COVID, we haven't been able to do this, looking at filtering through or sieving the clay that was found immediately adjacent to the specimen to see what we see there. Often you can find things like small sharks, scavenging sharks' teeth and things like that, and invertebrates which might have been scavenging on the carcass. And of course, we can also look at more larger things such as tooth marks on bones showing where things have been nibbled or gnawed and where things have been displaced. So we can start looking again, build a model, if you like, of how that carcass decayed and which bits were held together by more resilient soft tissues and which bits of basically just came to pieces. It's a complicated business, and to be frank, it's going outside my area of expertise, which is more to do with plesiosaur anatomy, but we can get people involved who know about these things and do some sort of collaborative work on it. But we have the information which people can work on. Okay.
Looking at your photogrammetric techniques, I saw somewhere recently they were using very sensitive LiDAR in an archaeological dig.
Yeah.
Have you considered that?
Wish we had the money. Yeah,
All right.
archaeologists have it made. They have lots of money thrown at them because they have the right to excavate a site if anything turns up. And they can stop construction processes. One of the frustrating things about paleontology is that if Fortera or Cemex had decided they couldn't be bothered with this specimen, we have no grounds whatsoever on which to get them to stop doing it. They could have churned it up and dumped it and made bricks or made cement out of it. And there's nothing we could do about it. Archaeologists, because they have this legal right, they also get funding and they can buy LiDAR. I'd love to get LiDAR, but you know, we'll have to, yeah. You have to realize this is all self-funded. So I mean, we've done these excavations basically by giving up holiday time and giving up our own time and actually putting our own money into it. So it's
tell me about it.
Yeah.
Next question from Chris Donnelly. Can you recap on the general difference in fossil finds between the Kimmeridge and Oxford clays? And do you know how this reflects on the different environments of deposition?
Right. One thing I have noticed as a difference between Oxford and Kimmeridge clays is that the Kimmeridge clay has bigger predators, and the style of predation appears to be different. So we have large pliosaurs in Oxford clay. We have an infamous animal called Pliosaur, which is probably 6 to 8 meters long. So basically an enormous predator. But the evidence for predation seems to be that it went in, it took off a flipper. We have lots of flippers, especially of Cryptoclidus, which have been bitten off with huge bite marks in them. And it seemed to me that Pliosaur's technique was basically to go in, take off a flipper, and then when the animal just swims in circles, take it. When we get into the Kimmeridge clay, we have these enormous pliosaurs. I showed you the picture of the Weymouth Bay pliosaur. That was probably 10, 12 meters long. The skull's more than 2 meters long. And there is some evidence that there were pliosaurs quite a lot bigger than that one around in the Kimmeridge clay. So when you look at Kimmeridge clay fossils, and a lot of the ones in, Steve Etchers has got some great examples, you'll find an ichthyosaur, which has been bitten clean in half. So the big predators in the Kimmeridge clay were that much bigger and that much more ferocious than the Oxford clay. We also had some quite big long-necked plesiosaurs. There's an animal called Columbosaurus, which is one of the longest long-necked plesiosaurs. But it seems to be in the sense that in Kimmeridge clay, everything went up a notch. Bigger predators, bigger prey. Kimmeridge clay, it's a deeper sea. And I think the bottom conditions were slightly different. You didn't have quite as much the soft sediment that you got at the bottom of the Oxford clay sea, which is possibly one of the reasons why we don't get so many well-preserved reptiles. Although, as I've said before, it might just be a collection bias.
Just following on from that question, Justin, was the plesiosaur you were talking about a Pleurodon?
No. It's Pleurodon is Pleurodon is really limited to the Calovian. The name has been used a bit loosely as a garbage bin taxon, and this material from Russia, which has been called Pleurodon, and we don't think it is. Kimmeridge clay, we have Pliosaurus, basically. One of the great things that came out of the Weymouth Bay pliosaur was that because the skull is so beautifully preserved, we could actually get a much better view of what the skull structure on pliosaurs was like. So when we did the paper on that one, we erected a new species, not just for that one, we called it Pliosaurus kevini, but also for 2 other pliosaurs, Pliosaurus westboriensis and Pliosaurus carpenteri. If you like, that single specimen helped to focus where the differences are between the different species, but they're all quite similar, and we can't see any reason not to call them all Pliosaurus. And that really is, there are smaller pliosaurs in the Kimmeridge clay, but none of them have yet been described. We know of odd bits and pieces which are much smaller, but those are waiting to be described.
Just a thought, these animals were carnivores.
Mm.
Has anyone ever found the remains of some of its meal in where the stomach would have been?
Well, the thing is, with the pliosaurs, because the fossils are so rare, we don't get nice articulated specimens. I don't know any articulated pliosaur specimens from anywhere. And also that there is another problem which has occurred, in fact, with a specimen from Cambridgeshire, from Streatham in Cambridgeshire. They call it Stratosaurus, but people kept digging up these vertebrae in a, I think it was a drainage ditch, and when people started digging, people came around and said, "Oh, can I have one of those? Can I have one of those?" And they were handing out the vertebrae.
Oh, no.
And they got scattered around. And afterwards, I went, "Hang on, can we get all these bones back again?" And not all of them did. And they were so that they were it wasn't exactly excavated systematically. Again, you know, when you have, the problem is always how the specimens are found, because, for example, on the Dorset coast, we have lots of specimens that come out, but they drop out of the cliff a bit at a time. So you don't have the opportunity, or you very rarely have the opportunity to go around and actually see exactly how it was when it was in situ and how it was actually found. So yes, you find ichthyosaurs with stomach contents, but then the Dorset coast ichthyosaurs are, I won't say common as much, but there are an awful lot of them around. There are some plesiosaurs with stomach contents, but only long-necked ones. But none of the pliosaurs that I know of have got anything in the stomach contents. Sorry, but one thing we do have, we do very rarely find the teeth of pliosaurs embedded in bones of long-necked plesiosaurs. But I know of 3 examples of that. So.
Cannibalism. You've got a volunteer here. So Megan Jenkinson is asking now that digs are starting back after COVID. How can you suggest someone could volunteer if they haven't been on a dig before?
Well, we try to encourage it, because I think it's useful to have bodies around. It's also a great experience for people to have. But if we find another specimen which requires excavation, we'll make it known. Well, obviously, members of our group will be invited to volunteer if they want to. There can be problems with that. So some of the pits are very careful about the numbers of people they allow on. We don't really want to have 50 people milling around, and also that makes it hard to control as well, because there's a gentle art to using volunteers on a dig.
Again, a question from Megan. You mentioned that there aren't many known plesiosaurs from the UK Alanian. Is that due to an absence of deposits, or might it be a reflection of the decimated populations?
Good
from
question.
The extinction below?
Good question. We don't get many Alanian deposits in this country, certainly. In fact, we've got some, but they don't produce decent marine reptiles. I've actually worked on a plesiosaur from Switzerland, which is Eilenian, and I think it's distinctive enough to set it up as a new species, but that would be the first species of plesiosaur identified from anywhere in the world from Eilenian. We have odd bits and pieces, but it does rather look, looking at very limited evidence, that there was a bit of a bottleneck there, that some of the big predatory plesiosaurs, such as the Romaleosaurs, which are big predatory pliosaurids, not related to the big ones, but they died out. And not many of the Jurassic clades made their way through. But again, that might just be a collection bias, or the fact that we don't get many deposits of the age which have been collected extensively. That's always the problem with all these things. There's so much more collection in this country particularly than probably anywhere else in the world. It's very hard to know if we are typical or we're just an outlier.
there's a secondary comment in from Malcolm Hart again, saying that Steve, presuming means Steve Etches,
Yeah.
as a specimen of the plesiosaur with squid hooks, probably in the stomach area.
Yeah. Yeah.
So if anybody, if you've never been to the Etches Museum,
Yes.
so the rest of the people, please go. It is fantastic.
It's the best. It's the best museum in the world. I mean, not stand biased, but I've seen it grow over the years because I've known Steve for 25 years, from when it was in his garden shed, admittedly an air-conditioned, insulated garden shed, to a second shed, to a third shed, to joining to his house, and now into his museum. And he's a fantastic. It's a fantastic achievement, and he's a great collector, because really, what I love about what Steve does is that he presents everything as it was found.
Yeah.
He doesn't make it look nicer to go on display. So what you see is what came out of the ground, and that, from my point of view, makes things so much more interesting, because it's telling stories. And I said, paleontology is about telling stories, but doing it based on evidence.
And if you're taking youngsters there, it's superbly educational.
Yeah.
They're learn a hell of a lot. There's one last question in from Martin, who says it might be naive, but what is deposited to make clay as opposed to chalk? And is it that good for fossilization? Well, clay is clay.
It's down to particle size. Once you get below a certain particle size, and I can't remember off the top of my head, it's a clay rather than a limestone or a mudstone. But what is one of the hypotheses about how the oxide clay was formed is that it's actually built up from shrimp droppings. And that basically you had a rain of very fine particles, which were quite organic rich, coming down off the seafloor, forming this soft, what they're called a soupy substrate. It's too soft to walk on and too thick to swim in, which has provided this lovely situation for preserving things. I'm not entirely sold on that one, because the oxide clay in some of the beds does actually fisher beautifully, and you can actually see trackways on it sometimes of invertebrates. But it's my friend Dave Martill once addressed to a group of people from the London Brick Company and said, "Your bricks are shit," meaning it quite literally they're actually made out of shrimp shit. So yeah, I mean,
interesting.
Yeah. Yeah.
The ones you were digging out of the Oxford clay, what's the bone material made of? Is it still bone, or has it been replaced, mineralized in some way?
It's permineralized. It's replaced. It's the apatite of the original bone remains, because that's a crystalline form anyway, and the softer elements of the bone are replaced by. You'd have to talk to specialists now, but it's a suite of minerals, but principally calcite. It does preserve the internal structure of the bone beautifully. I think there's a whole science to do with the way which works. It depends on the rate of formation of the crystals, how well preserved things can be. So if the crystallization happens very rapidly, then you get tiny crystals, and therefore you get beautifully, incredibly well preserved structures. If it happens more slowly, you get crystals growing and breaking things up a bit.
If the beast gets buried before the soft parts and the flesh gets rotted away, I presume that would change the pore water chemistry. That might affect its preservation. Yeah,
I mean, there is the rare places you get soft tissue preservation. It's where essentially where soft tissue contain phosphate, you get phosphatized soft tissues. So they're I think, I don't know all the details of how it works. You'd have to talk to someone who knows more about these taphonomy than I do. I know about plesiosaurs. But my understanding is that while you have the conditions under which that phosphatization can happen very rapidly, And there are places where they think it happened within a period literally of hours, or possibly even a few days, which is why you get these incredibly well preserved internal structures. It doesn't seem to happen. We don't get soft tissue in the Oxford clay, at least I haven't come across any. Well, there was a site called Christian Mulford out Hampshire, I think, somewhat Wiltshire, which during the 19th century provided some soft tissue preservation in Teuthids from the Oxford clay. And Neville Hollingsworth, who you might have seen recently digging up mammoths, found some Teuthids from the Oxford clay with soft tissue preservation from a site near, I can't remember where it was, but somewhere in that part of the world, somewhere in Hampshire, I think. But to my knowledge, nothing's been found in the Peterborough area. I mean, one of the very sort of unexplored aspects of all of this is the lateral variation in the Oxford clay. We know quite a lot about how the stratigraphy stacks up, although not, but there seem to be quite significant differences in the faunas you get in different pits, even if they're only a couple of miles apart. So in some you find loads of belemnites, in others you go to a pit 2 miles away and there's hardly any belemnites. In some you'll find beautiful 3-dimensional ammonites, in others you'll find only crushed ammonites. And underneath all them, there's a shrimp bed, which is around bed 7 in the Oxford clay, which apparently extends over a very wide geographical area, because you find it almost everywhere, which is full of shrimps. You don't find shrimp, well, you very, very rarely find shrimps anywhere else in the Oxford clay. One of the things I talk about is the episodic nature of the fossil record, that we're not recording continuous processes. It's not gradual buildup of stuff. It's an event happened which caused that fossilization. Then another event happened. Another event, it might have been a massive storm, it might have been an earthquake, it might have been a tsunami or something, but something really churned things up, killed a lot of animals, now preserved. And you get these beds extending over a large area with sometimes only have one kind of fossil in them. But they were obviously around during the rest of the time, but they don't get preserved.
Okay, couple of last questions for what we call it a day tonight. A day tonight.
A night tonight.
Robert Fodderson, have there been trace fossils of plesiosaurs and pliosaurs found in either Oxford or Kimmeridgian?
Trace fossils.
Trace fossils. Have they left any marks for the ground?
None that. I don't think that we don't really have the right conditions for preserving trace fossils. There have been some trace fossils described as coming from plesiosaur in a site in Switzerland, but to be frank, I don't believe it. But no, we don't have any trace fossils, certainly not Oxford or Kimmeridge Clay. The conditions are just wrong. And
last question from Chris. She was just wondering, the rhino skull, did you say it was from the gravels of the river Nene terraces?
Yeah.
Have you found much else in the gravels?
We found quite a lot in the gravels. This came from a site we go to near Peterborough, which is gravels on top of Oxford clay. And we've actually got a partial ichthyosaur from the Oxford clay, which is very nice. It's going to Nottingham Museum. But you find in the gravels, you find this interesting mix of stuff. You get a lot of reworked fossils. You get fossils washed out of the Oxford clay and the Kimmeridge clay, I think. So we find, I think I showed you a picture of a Rhinoceros humerus. That actually came out of the gravels. So it had been washed out of the Oxford clay. But also you find Ice Age fossils. So on our trips, some of our members got a big collection of Ice Age fossils of all sorts of stuff. In fact, a recent trip, one of our members found a hand axe. So there were people around as well. And with the rhino skull, we did find some other bones, which had obviously been scavenged by hyenas of the woolly mammoth, the woolly rhino. That is at Flag Fen at the moment. So it's there for anyone to see who wants to.
Right. Well, thank you, Richard. That was really interesting. it just makes you want to go out and start digging holes in the nearest clip it you find in the fens. Probably not a good idea. Well, thank you indeed for that. I think we are over 50 people log in for this one tonight. And can I just tell the listeners that remain that our next month's talk, which will still be virtual, is by Dr. Colin Prosser, again from Natural England. Geoconservation past, geoconservation, not conversation, past, present and future. So hope you can join us all then. And for this evening, again, once again, thank you very much, Richard. And good luck on your next digs. Goodbye, everyone.
Less than a mile from where it all began.
Goodbye. Thanks.
Bye.